Okay, we're doing rotate array 189 Leetcode medium. And yeah, we're just gonna get started right away. So let's see, given an array, rotate the array to the right by some number of steps where k is non-negative. Okay, so input is just an array of integers, and output is rotated array of integers. Okay. And looks like we're just gonna be working with arrays. So array to array. And let's see. Okay, so rotate. It's always to the right, it seems like, right? Rotate the array to the right. Okay. So this is k is 3. So as our rules go, we also have k. So positive integer value. Okay. Let's think. So just grab this test case. Yeah, we'll just look at it here. So k is always positive. Well, okay, non-negative. So is always 0 or greater. Okay. So rotate one step to the right. So from, I guess, okay, so from this, we're rotating one to the right. So looks like the 7 is being moved to the front. Okay, so that's one move, one rotation. All right, and then another rotation. 6, 7, 1, 2. Okay, so then the 6 is moved to the front. Okay, and then the 5 is eventually moved to the front, and so on. Okay. Is there anything else to this problem? Oh, they say try to come up with as many solutions as can. There are at least 3 different ways to solve this problem. Can you do it in place with 0 of n extra space? So just mutating the input array and adding no additional arrays or variables. Okay, I mean, yeah, I think so. I think that's definitely possible. Here they just give us some bounds as far as the magnitude of numbers and magnitude of the length of the input array, nums. Okay. I mean, this seems pretty straightforward. I have one approach that I can think of right off the bat. I think that there's like one where you would shift them individually. And I guess these 2 examples are leading me to think of only situations where k is less than the length of the input array, which is not always going to be the case probably. So I guess that might be an edge case maybe. So where k is greater than num's length essentially. So I still think that would be fairly straightforward. I think one way you might do this is getting so if k is greater than num's length, then we might want to use the remainder operator. Because like let's say k was like 100 or something. Obviously 100 is greater than the length of this array. So it seems like we would just want to get the remainder of whatever 100 remainder num's length is, and then whatever that operation produces will be the actual number of rotations, or I guess movements. And I think from there, like let's say let's use an easier number here. Let's say it was like, well, this is of length 7. Yeah, this is of length 7. So if we did like 23, so like let's say k was 23. So if we took the remainder of 23, so this would be 7, then the remainder would just be 2, right? Because 7 goes into 23 3 times. So yes, 7 times 3, 21. So then the remainder would be 2. So the correct result should be, in this specific case, would be shifting the last 2 elements, I think, right? Because every time we reach the length of the input array, like let's say we were just moving 7, we were moving the last element to the beginning of the array over and over and over 23 times. For every 7 iterations, that would essentially be returning it to the initial state of what it looked like when it was first passed into the function. So we can kind of just discard every time that happens, right? Like it's going to be the same. So once we, I guess, have done 21 times, we will have rotated this array 3 times, and then we still have 2 more shifts to implement. And so it seems as though it should just be that 6, 7, 1, 2, 3. So you could do that a couple of different ways. I think I want to do it like the individual movements way, but I still think this is a fair approach of getting the remainder if k is greater than the length of the input array. Okay, so I think that seems like a valid approach. So I think I'm gonna write some steps here. I'm trying to think if there's any other edge cases. I'm on maybe where num's length is 1, presumably, because it says it's always less than or equal to 1. Or I'm sorry, the num's length is always greater than or equal to 1. So there's the situation where the length is 1. In that case, we would just want to return the array, because if you're just shifting a 1 element array, that's not going to do a whole lot. Okay. So this seems like a good approach. And I think I'm going to do it the more verbose way, just for the sake of it. But yeah, let's get some space here. All right, so just gonna look at this other test case. 3 and then 99. Okay, yeah, so same situation. All right, cool. So I think the first situation, I'm going to just deal with this situation, this test case that I identified where num's length is 1. So we're going to write that out, and I'm gonna write it in the function itself, just with pseudocode. So guard for, actually, let's do it this way. So guard for input num's length being 1. Okay. And then once we do that, we want to check to see, check if length of num's, or if num's length is less than k. Yeah, so if it's less than k, then we know we can discard, we can streamline the number of operations required, like we were talking about earlier with the 23, k being 23 and length being 7. We just want to get rid of essentially 21 operations. Okay, so check if num's length is less than k, or if it's equal to k. Yeah, so check if num's length is less than k, and I think before that, check if, so I guess that's another perhaps early return. So guard for input nums being 1, then also k equaling num's length in which case we just want to return the input. So both of those situations are where we would just want to return the input unadulterated. And I think I can even probably extend that as well, because if it's perfectly divisible, so if k remainder num's length is equal to 0, then we can also just return the input array. So those are all situations where that makes sense. And then if num's length is less than k, I'm wondering, does this actually make sense? I think it does. Yeah, I think it does. So if num's length is less than k, then we want to, I think we're going to need to declare a variable here. So declare operations count. And I guess we can just initialize that to undefined for now. And if num's length is less than k, then assign operations count to the remainder of num's length, remainder k. So whatever that produces, whatever the remainder of that operation is, will then be the value assigned to operations count. Okay, and then once we get there, we essentially just need to loop this amount of times. So we can just use a while loop maybe. So while operations count, or I guess while operations count is not equal to 0, just do the following. And what we want to do is reassign operations count to, or I'm sorry, reassign nums. So reassign nums to maybe we're going to we basically just want to pop the last element off and then shift that element into the front of the array. So like removing the 7 and placing it in the front. So I think that would just look like maybe like an assignment like nums is equal to nums pop, and then we do nums, I believe it's unshift, right? Do I have that wrong? I think I might have that. I like always get these confused with between shift and unshift for arrays. Removes the first element. Okay, so were we right? Unshift, yeah, we were right. So we want to essentially push that element to the front. Okay, so that's what we're going to do. And since those are both mutating operations, we don't have to worry about reassignment here. And then once we do that, we just want to decrement operations count by 1, and then eventually just return the current value of nums. Okay. So that seems like a fairly good approach. Let's think about it with a test case. And let's think about it with the one I was thinking of. So how about like we'll say nums is just this given array and k is 23. So none of these are going to be evaluated. So then we move to this section, declare operations count, and we need to check to see if num's length is less than k. In this case, it is because 7 is less than 23. So we need to assign operations count to the remainder, and that remainder should be 2. So we'll just grab this, and that's 2 at this point. And okay, so now we're here. So while operations count is not equal to 0, so currently it is 2, do the following. So we're going to shift off the 7, and, or I'm sorry, we're going to pop off the 7 and unshift it into the front of the array. And then we decrement operations count and evaluate this expression again. Operations count is not equal to 0. So once again, we pop the last element off and push it into the front. Unshift, that's really awkward. That's an awkward, why is it called that? Unshift. I guess maybe it makes sense. It's not making sense to me at the moment. All right. So, and then after that, we need to decrement operations count by 1. So now operations count is 0. So now we're done looping through our, we're done with our looping. And then we just want to return the current value of nums. And that's just going to be this. So that is what we expected. And yeah, so that makes sense for that situation. Let's actually write out our function now. So just remove this stuff. So the first thing we wanted to do was guard, right? We'll just move some of that stuff down. So if nums length is equal to 1, we want to return nums, because regardless of whatever this element is, and I think I need another guard clause here for situations of k is 0. I think I do need that. Yeah. So if k is equal to 0, or k is equivalent to nums length, well, I think I can kind of combine these two situations, k equal to nums length, because both of these just mean we don't want to do any shifting, really. And really, that's actually the same for this as well. So if I think we can remove this one. Yeah, we can remove that one. Or if k is 0, okay, so those are both situations where we just want to return nums as well. So k remainder nums length is equal to 0, then we just want to return nums. Okay. And now we're looking here. So I want to declare operations count. Okay, so, and actually let's just leave it at operations. Okay. And we need to check if nums length is less than k. So, okay, if I think we want to initialize that to k, because there's a situation where this is not evaluated. So if nums length is less than k, then we want to assign operations. We want to reassign operations to the remainder of nums length divisible, or remainder k. So nums length remainder k. Okay. And so now that should work. Yeah. Okay. So we have that working. And now we need to set up our while loop. So condition was simply while operations count is not equal to 0, while operations is not equal to 0, do the following. Okay. and we just want to decrement and make the operation. So nums unshift nums pop. Okay. And once we've done that, we need to decrement operations by 1. And now we just want to return nums. All right, so let's run our code, see how we're doing. Okay, so we're accepted, runtime at 92. Let's take a look and see how we did with the other test cases. Wrong answer. Okay. Let's see. I want to see how much time I have. Okay. It's reasonable. So it's a 2-element array and k is 3. So let's just walk through our algorithm and see where we're going wrong. So popping and unshifting. So it would be 2, 1. But again, here, operations count should just be 1. And the 2 should just, it should just be 2, 1. So we're just popping and unshifting the 2 into the front. And that's the only operation that should happen. Okay. So if I were to, it's not either of these, and num and operations should be 1 here. Should be the remainder of taking the, oh, I see what I did. So the problem was that these are in the opposite order. We should be taking the remainder of k, so essentially just flipping these. I flip them. So in this test case, we're essentially taking the remainder, so 3 remainder 2. So 2 divides evenly, or I'm sorry, 3 divides evenly into 2 once with remainder 1. So that's actually where we're getting that. And it only just worked, I think, because of, for this test case, the initial accepted test case, is just because k is not greater than the length of the input array. So these are just in the incorrect order. So this should fix it. And if I apply that to our code, yeah. Okay, so k remainder there. So now operations count should be 1. Why would that be any different? This should still result in the same error. Okay. Okay, so the length is 2, k is 3, and if this length is less than, so if, okay, I'm gonna write this little in a way that's a little more digestible to me. So if k's length is greater than num's length, then we want to reassign operations. So 3 is greater than 2, so we want to get this value here. Yeah, so 3 remainder 2 would just produce 1. So there should just be 1 operation. And okay. So then operation should have an initial value. Well, first of all, it should have an initial value of 3, but then we reassign it to this value, the value produced by this operation. And so when we're running through a while loop, they should only execute once. Okay, so let's take a look. I feel like I think it should work. Yeah, I think it should. I think we fixed it. Oops. So we're exceeding the time limit, which means our approach is not very efficient. Okay. Why would that be the case? Curious. All of these operate. There's not really any much looping going on. I mean, this is always going to be, like, the amount of loops is always going to be less than the length of the array. So that's confusing. Right, because that's so say k is a very large number here. These sort of operations are really fast. Like they don't hog a lot of time. And I'm not like really even iterating over anything at this point. So that's a little confusing. And I don't think these operations are, well, it might be kind of slow because I mean, I guess when you are pushing something, when you're having to insert something into an array, that's actually a lot. Like, especially if you're inserting at the very beginning, you have to shift every element over by however many elements you're adding to the start of the array. So I'm curious, maybe there's something we can do here where we just have to do that once, right? That does seem to make sense. Yeah, I think I might want to chop off the end of the array and then just append it to the start of the array. So we just have to do these operations once, essentially. And so we wouldn't even really need this while loop. So I think that's what I'm gonna do. Yeah, I think that makes sense. So instead of like decrementing things, we essentially want to figure out a way to chop off the right number of elements. So let's say for the test case we were thinking of, which was like, where was that? Let's grab this one again. All right, so we're looking here, and let's say k is 23 again, right? So we just want the last two elements. So if I were to, I guess I would take the length of the array. Okay, so I think to get the last two elements, we just essentially need the length. So array length minus operations count gives us the index equals index to slice from, I believe. So this operation would just produce 5, right? That'd be the index. So 0, 1, 2, 3, 4, 5. Okay, so starting essentially just slice from 5. So 0, 1, 2, 3, 4, 5. Okay, yeah, so slicing from there. I think we just need to perhaps even just splice. Yeah, so I think I want to splice those elements and then unshift. I think I want to look at the documentation for unshift real quick. Unshift. Okay, so okay, so that could actually work fine if I do it that way. So yeah, okay. So new plan. What we're going to do is everything up to here is fine, but I think I need to let's do this way. So we're going to get starting index. So let's do const slice from index. Okay, and this is going to be array length. So num's length. So 7 minus operations, which in this case is 2. So that produces 5. So we want to, I guess it's splice or chop from index, to use a non-technical term. Chop from index. Okay. And oops, chop from index. Okay. And then we're just going to do nums splice. Okay, and then I gotta look up the splice. So that is starting. So start is the index at which to start changing the array. Okay. So then that's going to be 5. Okay, so chop from, and it should just be the end of the array. And if I omit that, yeah, I think I can just, and then this returns the array containing deleted elements. Okay, so I'm going to grab that, chop from, just grab that, and then we're going to unshift that into nums. Okay. I think that should do it. Let's take a look. Great. Okay, and it's really fast. So if it wasn't clear what I did, essentially what's happening here, and let's actually do some more self documentation. Const shifted, or yeah, what's this called? What's this rotate? Okay, so rotated elements else, and that's just going to be this expression here. So nums splice chop from. So chop from here, if we're thinking about this example, we're essentially chopping from index 5, which is the element at this index, and we just want to slice from that to the end. So we're just slicing from that to the end, and we're essentially assigning rotated elements, the variable, to that array, and then we're just pushing the individual elements, so we're spreading them, rotated L's, and then pushing them, or I guess shifting them into the front of the array. So 6 and 7 are then placed there, and that does produce one. It does produce some more memory, right? Like we're allocating memory for the new array being returned from num splice. But yeah, it's not egregious. So yeah, this is my solution. Not super clean, not really the best. I would say it's not the best showing for me, just in terms of overall approach and all that. But it was fun. Had a good time, and I think I need to go back and do some just general learning with the documentation. Just kind of forgetting some of the specifics about these various very important array manipulation methods. So yeah, a very much a learning experience. But yeah, thanks for watching if you've made it this far. I'm going to probably be doing at least one of these every day. But yeah, thanks for watching. Bye-bye.